Hello fantastic people, I hope you're doing great. Today we'll implement Knockback. So let's get straight to it. Here I have just a character we created as part of previous tutorials, so it can walk, it can jump, it can swing the sword, and that's really it. Yes, if you don't have any of those, don't worry, I will link the tutorials in the description. The movement one is pretty short. It lasts 3 minutes, so you should not have any problems with following it. The combat one is a little bit longer, but I think it's still worth having a look at. Now, the only new part is this ugly, angry block, which is nothing besides animated sprite and a collider 2D. So nothing fancy there, and this is our starting point. So today we'll create everything together. When you think about Knockback, it may seem as a little bit complicated, but it's actually one of the simplest features to implement, I think. That's because we have it implemented partially already. That's because we have jumping. And if you think about Knockback, especially when you jump on the enemy or something like that, or you fall on the enemy or on a trap or something like that, the knockback is in up direction. So it's literally nothing else than regular jumping, just with maybe a little bit different velocity depending on your game. Now, there is one tricky part, which is not too tricky, and it's really the only thing that might catch you off, which is the knockback to the x-axis. And that's because what we usually do when we have the platform movement, we tend to modify the velocity in the x-axis to move to the sides. And this is alright, this is okay, everybody does that, perfect. But what it means that every single frame we assign new x velocity. So if we have no input, the velocity will be 0. If we have input, this will be the speed, the movement speed. So it seems obvious, but it causes small problems. So basically imagine that we approach this block, we touch it, and we want to push the character away. We want it to kind of bounce off it, right? But now, if you think about it, what will happen, we'll assign a velocity to move it back, but instead of moving back, it will automatically stop, like literally the same frame or next frame. Why? Because, again, we modified the x velocity. So one thing to remember when you implement knockback is that when you because now this might be different if you use forces. This will be slightly different, but if you use the velocity-based solution, then you will have to disable the X movement temporarily to allow for knockback to kick in and work. Now let's go and implement the knockback. First, let's have a look at our player script. Important thing, if you get lost at any point, don't worry at all. You will be able to find all the code in the GitHub repository linked in the description. Now, first thing is we'll need a position in the center of character, because depending on your implementation, depending on how you handle animations, the center of the character or its pivot point. So the pivot point is the point from which all the transformations are calculated. So, for example, in my case, you see the character, if I open its collider and put an icon here, you see it's over here. And this is quite problematic, because if my character would collide with the block standing on the ground, it would be actually, you see, lower than the block, which is not true. So what we want to do, we want to create a empty object that is child of our character and call it center. Now we can assign it icon and keep it in the middle of character. I think I would like to have it over here somewhere, or even a little bit higher. Great. Now we'll need to store reference to that point, but first let's move our character a little bit back. Then in our player script, I will add reference for that. So I have movement variables, and I think that will be good place for it. So serialized field, private transform, and then center. Okay, that's great. We have that. Now we need a script which will trigger the actual knockback, and we'll have it on the angry block. Now, because I want to use this script on other things as well in the future, I will not call it angry block, but rather knockback trigger, for example, because it triggers knockback. Now I assign it to the angry block, beautiful, and open the script. Now we'll implement the on collision enter to the method, on collision enter to the method, beautiful. Now first thing I do is I check if I am colliding with, or maybe not I, but rather if the angry block is colliding with character. To do that, I can try to grab the component player from the collider and then check if it is not null. Beautiful. How it works is very simple. Basically, character walks up, collides with the angry block. The angry block sends the reference to this method. So the thingy that is passed here is the information about collision. One of the information that comes as a part of it is the collider. So that's the object that collided with owner of the script. So in our case with the angry block. Then I use the get component of the type player from that collider. Get component is very handy method because if there is no script of that type, it will return null. That means I can check if it is not null, and if it is not, that means I collided with a player. Beautiful. Now, what we want to do here is we want to actually trigger the knockback. And we don't have that method yet, that's true. We'll create it in a second. But before we do that, let's pass here one more bit of information. That's transform of the angry block. We'll need that to calculate the direction of the knockback, because it will be based on the positions of those two objects. Now, I'm using magic of my IDE to generate this method for me. If your IDE doesn't do that for you, just remember that the method has to be public, because we want to call it from another script, and that it has to take the transform parameter. Yes, so first, before we start implementing the method, let's create some variables. So first one that we'll need is we can actually move this one to a separate section called knockback. And then first field will be the center. Then we want another one, which will be the knockback velocity. Great, we could actually assign something by default here, so let's maybe do 8. And do we need anything else? Let me think. If we need, we'll get back here. So the first thing we need to do is to calculate the direction of the knockback. We can do that by subtracting from one position another position. So what we do, we subtract from the destination the origin. So in our case, if we have a look here, let's just say my character is over here. So if I touch the block, I want to go away from it, right? So the character's position will be the destination and the origin will be the block's position. So we have direction. Now we want the transform position, so the position of the character minus provided transform in the parameter position. Beautiful. And here I get the direction. We can start by debugging it. Lock. Beautiful. Just to see that everything works as expected, we can straight away assign the center. We'll need that in a moment. Great, so in x-axis minus 1.2, which is good because it's to the left. Now, okay, so we have minus 0.8 in the y-axis. That's because we forgot that we should be calculating it not from the middle of the character, but from the center of the character. So let's do that now. Center transform. Actually, we stored this transform, so we can do that. Beautiful. Let's test the direction once again. Now I collided from the side. Awesome. In the y axis it's almost 0. Here exactly 0 in the x, and here exactly opposite in the x-axis from the first one. Everything seems to be all right. Now back to the script. So we have the direction. Now what we have to do is rigid body, velocity. Now we want to do the direction normalized times, and we want to multiply it by the knockback velocity. Knockback velocity. But as you remember, we have a small problem, which is our x movement. So we have to handle it somehow. But for now, let's just create a private variable. Now let's make it maybe serialized so we can test it from the inspector. Private bool knockback, and it starts with false. Then what we will do here is we apply horizontal movement only if we are not knockbacked. Pretty simple. This is just a temporary solution, but this will get us going. So now we want the knockback to true, and obviously we'll use the coroutine to set it to false in a moment. Let's make sure I saved it, and let's test it out. So I'm approaching from the left. Whee! Of course we are not slowing down because we didn't implement that yet. In the app. Yay! Uh-oh. Yes, the X movement doesn't work, but the knockback, the initial idea of it works. So now we have two last bits missing, which are: first, we have to set the knockback back to false after some time, and the second one, we have to apply some friction or slow down somehow the character when the knockback is happening. So first, let's handle setting knockback to false. For that, we'll use coroutine. If you want to learn something about coroutines, if you are not sure what they are, I talked about them in the previous video, so I will also link the tutorial in the description. Now, let's implement the coroutine. IEnumerator. The coroutine always has to return the IEnumerator. Then what I do here is I unknockback. Yeah, that will do it. And then set the knockback to false. Now, forgot the most important part. Yield return new wait 4 seconds. And now we have to decide how long the knockback should be. I think something around, we can start with something around second. Actually, let's move it also to the variable. So yet another variable over here, serialized field, private float knockback time, and let's start with 1 second, and then at the very bottom use it in the coroutine. Now start coroutine and knockback, and beautiful. So this should be enough to get us unknocked and turn the movement back on. So here we move. Yay! Yep. So you see 1 second passes and I'm able to it's a little bit long, but here also you see I can move after that happens. So, but I think the knockback time is a little bit too much. Let's try half of the second. Yep, that's much better. We'll still need to implement the friction thingy. Awesome. So let's change it to half a second. And now in our knockback velocity, in our apply movement method, when the character is knockbacked. So else what we want to do, we'll want rigid body velocity to be new vector 2. We want to keep the y because y velocity because it's handled by the gravity, so everything's all right there. And we want to slow down movement in the x-axis. To do that, we can use lerp. So we can do vector. No, we can actually, yes, because it's between two regular values. Lerp, no, wait a second. Let me think. Var velocity, that will be float lerp, no, math f lerp, yay, that's it. Yes, okay, so we have the lerp method and we want first the source, so not the source but the initial value, so that will be the rigid body x. Then it will be, the target will be 0 because we want to approach 0, and then we want to modify by let's do time delta time at the beginning, and let's see what will happen, how it will work. Should be fine. Maybe we'll need to adjust it a little bit, but yep, it's slowing down a little bit too slow, so we can try that times 3. Yep, I like it. So here we have a simple knockback. The reason you see it speeding up at the end is because when the time passes, so when the knockback time passes the half a second, the character is slower than the actual horizontal movement speed. So basically if I wouldn't touch anything, so do that, well, you see it stops and it's fine. But if I try to walk, basically the character will suddenly speed up because it's the regular speed of the character is higher than the speed at which it finishes knockback. I hope it's clear. Yes, so I think that's it. The one thing I would change, and one very minor thing I would add, Yes, so first, I don't like this part. I don't think we need to create two separate vectors for that. So what we can do instead is we can create new x velocity. In general, in the script I use everywhere vertical velocity, so let's keep that this way. New x velocity. Then what I will do, if the character is knockback, then we calculate, we use this one. Otherwise, we use this one, and here we can remove that, and use this one. Isn't it much cleaner and much more beautiful? Great, so here we are. That's the first thing I wanted to implement. Let's see how much time. Yeah, we can do that too. So what I would like to do, I would like the character to get flashed, like the, you know, blinked. In white it will be pretty difficult because we would have to create shader for that, but let's make it blink red. So we can do that by grabbing the renderer. Do we have it somewhere? No, so let's quickly add it. Private sprite renderer, and now sprite renderer. Now we grab it in the start method, component sprite renderer. Awesome. And then what we do here, what we will change is the color. Let's change it to red. And now why I say white is impossible, because the white is actually this regular sprite without any color applied. So as I said, for that you would have to have custom shader, which we'll do sooner or later, but it's definitely not time for that. And I think after this half a second we can or let's make another crazy coroutine, which will be private enumerator fade to white. Now what we'll do here, while the character is while the sprite renderer color is not color white, oops, the wrong ones here, what we'll do, we'll assign its sprite renderer color, and now colors I think also can lerp. Yay, they can. So what we do color red, then to color white, and then we use again time, delta time. We want it a little bit quicker probably, so let's do it ×3. And now, because we don't want it to happen instantly, we want like, you know, happen at every frame. So what we can do here is yield return null, and that should actually do it, I think. Let's test it out. If it will not work, I will cut it off. So, sprite renderer attached? Of course not, because as I said in the previous tutorial about the coroutines, we have multiple sprite renderers, not one. So we have to get all the sprite controller renderers, because the character is modular, you know, the head and legs and everything is separated. They are separate components, so we have to grab all the sprite renderers separately. So quickly private void, no, yeah, let's do it this way. Change color, now color, target color, and now we want to get all these sprite renderers Or maybe no, sorry. Yeah, just want to make it a little bit cleaner and quicker. We shouldn't every frame get these sprite renderers. So what we'll do here is get components in children. That will give us all the sprite renderers, and now instead of sprite renderer we'll call it sprite renderers and change it into the array. Now that should work. Beautiful. Then in the place where we change the color, instead of doing that, what we'll do that for each. Boom. Beautiful. Now, so for each sprite renderer we assign the color, and the same thing will be over here. Beautiful. Now sprite renderers 0, so we check on the first one, and that should do it. Yes, let's check it out. Uh-oh, it's not getting back to white, not good. Why? Oh, of course it's not, because we want to use this sprite renderer color. So what it does, lerp is going from the target, from source color to target, and it changes like the amount specified in the time delta time. So the mistake here was I used the constant red, so every frame it was trying to change from red instead of changing to from the color which is already on the sprite renderer. So we have nice blinking. Yay! Beautiful, everything working as expected. Have a fantastic day, love you, and bye bye.